Hello students, welcome to the physics class with Sujit sir. In the previous class, I have given you a question based on the principle of quantization principle of electric charge. Quantization principle of electric charge. That can a body have a charge 12.2 into 10 to the power minus 19 Coulomb? This is my question. We have to solve by using the formula Q is equal to plus or minus Ne, where Q is the charge of the body, N must be an integer, it cannot be a decimal number, okay, and E is the elementary charge. And what is the value of E? 1.6 into 10 to the power minus 19 Coulomb. Okay, now so let us see how many of you have solved this question. Match your answer with my answer. Okay, here we can, it is given charge of the body is 12.2 into 10 to the power minus 19 Coulomb, and we know that E is equal to 1.6 into 10 to the power minus 19 Coulomb. We have to find out N. If this N will be an integer, then the answer is correct. If this N will be a decimal number, then it must be the body cannot have charge this much. Okay, so let us find out. We know that Q is equal to Ne plus or minus Ne. Okay, that implies N is equal to Q by E. N is equal to Q by E. So that is equal to Q 12.2 into 10 to the power minus 19 divided by E. What is the value of E? 1.6 into 10 to the power minus 19. Okay, so 1.6 into 10 to the power minus 19 Coulomb. While dividing 12.2 with 1.6, we can get 16 into 7, 112. Okay, so I can put 7, okay, 112, then 10 remaining. So 16 into 6, 96, 4 remaining, and 112, 10, 96. Okay, 4 remaining. So 2, 7.62 and 10 to the power minus 19, 10 to the power minus 19 gets cancelled. Then our answer is N is equal to 7.62, which is a decimal number. But according to quantization principle, N must be an integer, it cannot be a decimal number. That's why this body cannot have a charge 12.2 into 10 to the power minus 19 Coulomb. You have to write here, the body cannot have a charge 12.2 into 10 to the power minus 19 Coulomb because N is equal to 7.62, which is a decimal number and it is not an integer. So the answer is like that. Okay, now we are going to study about Coulomb's law. Okay, we know that according to the properties of electric charges, similar charges repel each other and dissimilar charges attract each other. But we know that the attraction or Coulomb's law states that the force of attraction or repulsion between two charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Square of the distance between them. It means if consider two charges A and B, charged body A and B having charges Q1 and Q2 respectively. Consider two charges Q1 and Q2 placed at A and B respectively, and the separation between them is R, and the separation between them is R. Now we want to find out the force between these two charges in scalar form and again in vector form. First we have to find out, here we are going to find out the force between them in scalar form. As per the statement of Coulomb's law, here it states that the force of attraction or repulsion between these two charges is directly proportional to the product of their charges. That means this force of electrostatic force of attraction or repulsion between these two charges is directly proportional to the product of their charges. What is the charge of these two bodies? Q1 and Q2. So product of their charges, that means Q1, Q2, Q2. And again it states that, and it is inversely proportional to the square of the distance between them. That means force is inversely proportional to the square of the distance between them. What is the distance between these two charges? R. So square of the distance between these two charges. F is directly proportional to Q1, Q2, and F is inversely proportional to the square of the distance between them. It is the scalar form. Okay, F is inversely proportional to R square. So now combining these two, we get F is directly proportional to the Q1, Q2 by R square. Q1, Q2 by R square. That implies when we put equal sign in place of proportional, then we have to put a proportionality constant. Let it be K. Then it will be K Q1 Q2 divided by R square. So F is equal to K Q1 Q2 by R square. Now this is the Coulomb's law. Okay. So what is the electrostatic force according to Coulomb's law? F is equal to K Q1 Q2 by R square. Now this K is proportionality constant, The value of K is, in SI system, the value of K is 1 by 4 pi epsilon, and in CGS system the value of K is 1. So here we can write, in SI system of unit, K is equal to 1 by 4 pi epsilon. What is epsilon? Permittivity of the medium. What is epsilon? Epsilon is the permittivity of the medium. We have to remember these values. K is equal to 1 by 4 pi epsilon. Now epsilon is equal to epsilon naught into epsilon r. Epsilon naught into epsilon r. Epsilon is equal to epsilon naught into epsilon r. Epsilon is the permittivity of the medium in which these two charges has placed. It means if these two charges has been placed in water medium, then we have to find out permittivity of that medium. Then we have to put that in 1 by 4 pi epsilon. Okay, but the value of epsilon r is relative permittivity. And epsilon 0 or epsilon naught is permittivity in free space. So but the value of epsilon naught is 8.854 into 10 to the power minus 12 Coulomb square per Newton per meter square. Coulomb square per Newton per meter square. This is the value of permittivity in free space or in air. Okay, you can write both the permittivity in free space or in air is 8.854 into 10 to the power minus 12 Coulomb square per Newton per meter square. Okay, so these are the values. When the medium is air, okay, let us suppose we have considered these two charges Q1 and Q2 and it is placed at which place? In air. That means in this place. Okay, this is air medium. Here we have put these two charges, or on a table we have put these two charges. The medium is air medium, so we can put directly as, and in free space epsilon r is equal to 1. In free space epsilon r is equal to 1, that is relative permittivity is 1. That's why, so in free space epsilon r is equal to 1. That's why, so epsilon is equal to epsilon 0 into epsilon r. Here we have to place 1. That's why epsilon becomes epsilon naught. So in free space we can write k is equal to 1 by 4 pi. In place of epsilon we can write epsilon naught. So k is equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. Okay, so we have to remember all these values and formulas. K is equal to 1 by 4 pi epsilon for any medium. In free space k is equal to 1 by 4 pi epsilon 0. Okay, and epsilon relative permittivity in free space is 1, and epsilon is permittivity of the medium. Epsilon 0 is permittivity in free space. Epsilon r is relative permittivity. Okay, so we have to remember all these values. Now you have to remember k is equal to 1 by the value of 1 by 4 pi epsilon 0. What is the value of 1 by 4 pi epsilon 0? 1 by 4 pi epsilon 0 is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Newton meter square per Coulomb square. When you will divide 1 with 4 pi and epsilon 0, what is the value of epsilon 0?